Hi, folks. A very good evening and thank you for joining in. Could you just confirm in the chat window if everything is looking good? If you can hear me, if you can see my screen, if you can see my webcam. Can you please confirm that? Okay, I'm also checking it on my phone. Everything looks good. Cool, cool, cool. So let's wait for a couple of minutes. At 7:02, we'll start the class. Okay, so let me write that here so that it's clear. The class starts at 7:02. Let's give everybody a couple of minutes to join. Hey Dhimat, hey Natarajan, hey Anurag. Hey, very good evening. Again, at any point, if there is any sort of glitch, the updates, I will post it either in the chat window where I'm chatting, or I will post it in the comment section under this video. Okay. Okay, so there's a nice question which I'll answer while others join in. So Sandeep has a question which is, what is the thought process that we need to follow while designing a CNN architecture? Is it just trial and error, or there is some thought process to it? So first and foremost, you should always start with the problem definition, right? So I would say as your baseline V0 model, try and find one of the well-studied models which is relevant in your context. For example, if you want, let's say, a model which you want to run very quickly, right? And if you have less training data, it makes sense to use a fewer parameter model like MobileNet. Right? Of course, there are hundreds of CNN architectures. What I would always do is pick the closest architecture which is well studied, which is a standard architecture that I think most likely fit my requirements, whether in terms of how much data I have, the task that I want to do, or more importantly, do I want the model to run on a GPU, CPU, on a IoT device? Based on that, I pick the model first, right? Then train the model. The way to debug and improve the model would be to look at those data points in your validation data set where the model is not performing as you want, right? Very often, in at least 95+% of cases that I worked in CNNs, if you clean up your data and use a good standard well-studied model, 95% of the cases your systems will work. What a lot of people don't do is they don't go and see, hey, where is my model failing? They just look at a metric, they say, my precision is this, my recall is this. They don't see on what types of data points or what types of inputs is my model failing. First, do that analysis. And probably for that type, try to understand if you can clean up data, or if you can do some pre-processing so that those errors can be avoided. Otherwise, if you want to go ahead and do the architecture design, ask yourself, are you overfitting, underfitting? Where do you stand in the landscape of overfitting and underfitting? Based on that, add more data or add more layers similar to existing layers. That, again, it's not just pure trial and error. It's a very sensible, directed trial and error based on what types of points you're making errors on. Where do you stand in the overfit, underfit, or bias variance trade-off landscape? And for your task, what is the model that you're using? That's how I would think about it. So does that make sense, Sandeep? Cool. What about looking at gradients? Of course, Sandeep, that's part of, looking at gradients is also important. Like, for example, I mentor a few computer vision startups. The first thing I say is, of course, looking at gradients comes later. First, look at places where the model is going wrong. The gradients will tell you if you're having a saturation or if you're having an explosion, or on some points, your model is not at all training at all, right? Then you can come up with hacks like giving more weightage to that. All those hacks you can come to. Of course, looking at gradients is like looking at distributions of gradients is a no-brainer. That you should anyway do. Okay, cool. Sounds good. So I see some of you said, "Hey, can I have a discussion with you, folks?" My suggestion is this, which is, please email us your queries. Either one of my co-founders or I will reach out to you and try to resolve your queries as best as we can. either through an email or through an audio reply. If you think even that is not sufficient, your issues are not getting resolved, we are happy to set up a time with you, call you and discuss. Okay. Cool. Sounds good. Okay. So let's continue where we stopped. Okay. So today's discussion, let's get into the core of it. Okay. The most important thing today is, again, we have already overshot. It's already 7:04. So let's get to the crux of today's discussion. Again, I see some more miscellaneous questions about various aspects in the chat window. Please do reach out to us via team@appliedai course email. One of my co-founders or very senior employees or I will resolve it for you. Okay, so let's get into the core of today's discussion. Today is an interactive interview session specifically for ML engineer roles at top product-based companies, right? So at top product-based companies. Now, when I say machine learning engineer, let me define this very clearly. Machine learning engineer typically is a combination of somebody who has the data scientist skills, right, with some knowledge of software development. Now, when I say software development, you don't have to be like a software development engineer, but you need to know how to write code, time and space complexity, how to productionize models, all of that. And I will use the typical hiring bar at FANG. When I say top product-based companies, I mean MANG or FANG-like companies, right? So that's the bar that I'll use. And many of these questions are variations of these questions we have seen being encountered by folks at MANG-like companies. Okay, so let's get started with today's first question. Okay, so the question is this. Again, just like in the previous sessions, I want you to share your ideas with me as we go. So I want you to share your ideas with me, and again, we'll go back and forth, just like any other interactive session. So here is my question. My question is, can you implement the evaluation time, the evaluation code for logistic regression? Again, you please share your ideas. Suppose I want to evaluate a logistic regression model, right? So what does evaluation mean? Evaluation means, just to be precise so that we are all on the same page, I give you a query point, you have to return my this, YQ hat, right? You have to give me the probability given XQ hat. This is what evaluation means, right? So can you implement the evaluation code for logistic regression for low latency and high throughput applications? How do you think about it? Again, this is a simple question. Again, I've been through interviews where just on a single question, people can go very, very deep, and you can spend a whole 1 hour discussion just on this. But today I'll go a little deep, not too deep, and then we'll go to other questions. Okay. So can somebody help me with the thought process here? Is the question clear to everyone? Saujanya, okay, cool. So if somebody has suggested that you can discuss in the live session, let's finish these questions. I'll spend the last 20 minutes or so taking general questions. Okay, I'll do that. Okay. So somebody is saying, I'll just implement the code for sigmoid W transpose X plus B. Okay. Okay. So there are some clarifications. What does high throughput mean? Okay. So low latency, everybody understands, right? Low latency basically means that I should be able to evaluate this. So because this is my XQ, this is my YQ hat. Low latency means I should run it in a few milliseconds, very fast. High throughput means I should be able to run lots of queries per second on, like, if I want to say I want to run for 10,000 query points per second. This is what high throughput means. Again, if you have, especially at internet companies, you want to be able to run models like these in large numbers on, of course, I can just use a cloud to do it, but then my expenses will grow, right? As a machine learning engineer, your job is also, first of all, you have to understand what happens within a logistic regression, and you say, if I have to implement this in code for production for low latency and high throughput, how would I do it? Aren't both same? Not necessary. Not necessary. So just because you have high throughput, again, I can have, suppose if I just want high throughput system, I can build a distributed system, right? They are related, but not the same thing. It's very important. Of course, imagine I want to do this in a single server setup. Again, I can make the problem much more complex. Let's assume I have one single server, right? A high-end server box. I want to use it. I want to do this in a single server. So imagine if your manager comes to you and says, hey, we have this logistic regression model. Please deploy it on this single server. I want to serve as many queries as possible per second, as fast as possible. Avinash says, aren't both the same? They're not. Think about it. Why are they not the same? So Sandeep says, we need to use distributed system. Not necessary. I'm giving you a simpler variation. We can also dive into the distributed systems. So my setup is this. My setup is I have a single server. If you go to distributed systems, there are more challenges. We'll solve that later. Okay, so this is the mathematical function that we have to implement. Okay, how would I implement it? How do I implement it fast? Venkatesh has one idea. Okay, I like the ideas. Okay, his idea is, hey, use L1 regularization to remove useless features. Okay, fair enough. Let's assume all that has already been done. This is a good idea. So that by number of features have reduced, this is done. The people who designed it have already done that. You have the model with you. So, okay, now Sandeep says you have to do sign of W transpose X plus C. No, Sandeep, you can't do that. What I want is a probabilistic class label. I want probability YQ equals to 1 given XQ and my model. Right? I don't want a binary class label. I want a probabilistic class label. Okay, another good idea that somebody is saying here is let's write code in C. Okay, good idea. Certainly, writing code in C is obviously fast. Agreed. Cool. You should write, I've written some of this code in C, C++, and Java in the past. So this is surely a good idea. But beyond, of course, the programming language will come to later on, but can you suggest me ideas which are programming language independent? Okay, that's one other nice idea is, hey, let me see. Okay, Anurag has a very nice suggestion. Anurag says, hey, let's use multi-threaded code. Yes, very good. Very good idea. Good. Somebody asked a while ago, right? What is the difference between low latency and high throughput? If I use all the cores, imagine if my single server typically will be like a 8 core or a 16 core or a 32 core box, right? If it's an Intel processor, I can also get a lot of multi-threading, typically 1:2 multi-threading, right? So using multi-threaded code, perfect, very good. Use multi-threaded code so that you get higher throughput. So each of your, suppose if I get, let's say, suppose I have a setup like this, right? I have XQ1, XQ2, XQ3, XQ4, so on and so forth. I'm getting all of them very, very fast. So what I can do is I can send this to, let's say, core 1, thread 1, right? I can send this to core 1, thread 2, right? I can send this to core 2, thread 1. So what's happening now is my throughput is increasing. But within core 1, thread 1, I still need a low latency system. Don't forget that. Does that make sense? So using multi-core will improves my throughput. This is a very ingenious idea on a single server to improve, right? But of course, on each core and thread, I still need a low latency system. Does that make sense? Somebody asked this question, right? Aren't the same? Does that make sense? Okay, I see some general ideas like parallelize it. So let me write some of the ideas that you guys are saying. Some of you are suggesting let's use vectorization. Okay, so the problem, okay, vectorization. Some of you are also suggesting perform dot product, right? I see this dot product using parallel processing. How? Again, these are the details that you have to think of. How do you use this? If you're trying to use all the cores, right? Suppose if you're trying to do this in a multi-threaded fashion, do you even need that? Suppose if you try to do this in multi-threaded, suppose you're computing the W transpose XQ, right? The dot product using parallel processing. What are the problems that you'll encounter? Or what are the advantages and disadvantages? Since somebody said this, right? Vectorization is basically the same thing. Of course, vectorization has more nuances, but imagine I distribute my dot product computation in a multi-thread code. What is the disadvantage of this? Again, I'll come to other ideas. This is, I think, a suggestion from Avinash and Natarajan. Is the question clear? Again, somebody gave me an idea. I'm asking a follow-up question. Is the question clear? If it is clear, please let me know. Again, whenever I'm looking down, I'm looking at your comments. Folks, is the question clear? See, I suggested one idea. Okay, this is one option. In this option, I am passing, I'm doing parallel processing at the level of individual queries. All right. Here somebody is saying do parallel processing or multi-thread processing for the dot product itself. Okay, wait for all the course output in order to give final output. Okay. So there is a possibility of multi-thread code blocking for others. Actually, the biggest problem in this is this could improve your latency, right? If and only if the dimensionality of your data, the dimensionality, which is number of features, is very large, right? If your number of features is very large, this can improve latency. But again, this has a disadvantage, which is when you do parallel processing, right? You might have to wait for other threads to complete and share the data. All that sharing of data, waiting for other threads to complete, that's an overhead, right? So there is obviously an overhead of multi-threading, overhead of multi-core communication, or multi-core processing and communication. That overhead is there, but this overhead is still all right if this is very large. But there is another fundamental problem. This would decrease your throughput. This would decrease your throughput as compared to this option, because all of them this can increase your throughput. Right? This can increase your throughput. Does it make sense? Does it make sense on why this may not be the most ideal choice? So Tulsi, you're right. This is called model parallelization. Very good. I'm glad you used the terminology. This is model parallelism, right? So this is model parallelism, where I'm trying to evaluate the model using parallel processing. This is data parallelism. Data parallelism could be, for this case, data parallelism may be better because the cost of evaluating logistic regression is small and I need a high throughput system. Okay, cool. Now I saw some more nice ideas from others. Dhimat has a very nice suggestion. So let me write all suggestions that people have given. So Dhimat's suggestion is, hey, use caching. You cache your, So he has a very nice idea. So I really like that idea. Okay, so the idea is, he's saying, hey, cache your input, and perform matrix multiplication. That's a nice idea. I'll tell you what this means. It's a good idea. Okay, so the idea here is as follows. Suppose you're getting your xq1, which is a d-dimensional vector. Cache it. Maybe wait for a few, maybe wait for 1 or 2 milliseconds. You'll get lots of queries, right? You get xq3, right? Wait for them. Right? Suppose you get a matrix like this. Suppose instead of multiplying every vector with the weight vector, construct a matrix. So you're caching the input and constructing the matrix. Multiply them with your W, right? And matrix multiplication, especially for matrix multiplication on Intel processors, especially Intel server processors, which are called Xeon processors, right? There is a lot of internal code optimization when you do matrix multiplication. This way, you can get effort. Again, there are two ways. You have to experiment. There is no single solution. This can increase your throughput. But there is a small risk. Be careful. Again, you have to experiment. be careful of increased latency. Okay, this you have to be very careful of, and you have to experiment. There is no solution to this. You experiment and say, right? You experiment and say how many, experiment the cache, the size. Experiment the cache size. Suppose your system says, hey, I have to return within 10 milliseconds. Then you can't cache for too long. You can only probably cache for 1 or 2 milliseconds. So the cache size, here the cache size is 3. Right? So only 3 inputs you're caching. That experiment you have to do. It's a very nice suggestion. Who said that? Dhimat. Very nice idea. Again, these are all real world challenges which have to be considered when you design solutions. There will always be a trade-off between throughput and latency. Oh, of course, Sandeep, that's true. But the question here is, the purpose of this question is to see how you think. It is not for you to design the final system. It's to see how you think, what strategies you're coming up with. Okay, cool. This is nice. Okay, is there something else? So Sandeep suggests that we can use GPU cores. You can't. GPU will make your whole server cost shoot up by at least 4 to 10 times. You don't have a GPU at your disposal very often. Like I know some of the world's largest tech giants, which run billions of queries an hour, or billions of queries, not an hour, a day, billions of queries a day, which still run on Xeon processors or their custom processors, which are CPU heavy, not GPU heavy. Because imagine at Google scale or YouTube scale or Amazon scale, running everything on GPUs is super duper expensive. Okay, so these are good ideas. Any other thoughts? Okay, so this is good idea. This is certainly good idea. This is done. So vectorization, all this, there are always trade-offs, right? So there is always a trade-off, but still good ideas. This is certain. Data parallelism is certainly a good idea. Cache input is certainly a good idea. Any other ideas? One of the learners whose alias is Amin says, can we use memoization? How do you use memoization? How do you use memoization? So Sandeep is saying, so cache plus vectorization parallelization. No, think about it this way. No, I didn't say vectorization, right? Again, vectorization is also provided on Xeon processor, the raw machine level code, right? In some of the more recent versions of the Xeon processors, this is available for you. And vectorization actually happens in matrix multiplication. So again, I'm not saying there is one solution. I just want to see how you think. So data parallelism is very common. Model parallelism less common unless I have large number of features. Typically caching input, of course, you have to experiment and see if it works. Okay, storing the query and result. Okay, Jyoti, why would that be a big issue for me? Because anyway, I get my XQ, I get my YQ. There will be another process on some other computer which will store and log all of the data. That's not a key headache for me, because I'm more worried about get the query as fast as possible, get XQ, return YQ hat. All that storing and all will be slow processes that I don't have to worry. Or I can just send that data to another server. That other server will store it to disk. Can we reduce the dimensions of weights and query point to increase latency without much effect on performance? Can we reduce the dimensions of weights? That you can do, right? L1 regularization. Avinash, somebody suggested this already. Sandeep has a suggestion. Sandeep is saying, can't I do memoization like this? So his idea is interesting. His idea is this. Of course, there's a problem in that idea. So he's saying, I will memorize. Instead of calling it memoization in dynamic programming, let's just call it memorization. Right? So his point is, hey, if I know my XQ, right? If I've already computed my YQ hat, I will just store these pairs as key values. Okay, I'll just store this as key values in a dictionary, right, in memory. And if somebody queries the same input again, I will generate the same YQ hat without any evaluation. That's a good idea. But can you give me an example where this would work and where this would not work? It's a good idea. So all the previous XQs and YQ hats which I've already computed, I'll keep it. Can you give me a real world example where memorization of previous results, memorization plus caching of previous results, caching of previous results, where does this work and where does this fail? In real world, give me an example. So Dhimat says, is the pre-processing of XQ already done? Let's assume it's done. The code that I'm writing is, I get XQ, I want to give YQ hat as fast as possible. Interesting. Okay. So here the dictionary may add to more space being consumed. Actually, let me give you an example where something like this might work. Suppose imagine if you have search queries. If you have search queries, if each search query is my XQ string, suppose I have a string which is encoded into a vector, that pre-processing is already done, right? If the search queries repeat, typically if you see the distribution of search queries, right? Search queries distribution, right? There is a lot of repetitions of the same search queries. Imagine if there is a football match that's happening. People search for the football match results very often. In such a case, caching can be helpful, right? Lots of repeated. So if you have lots of repeated XQs, right? If you have a lot of repeated XQs, this is a good idea. On the other hand, look at something like advertising, right? You want to say, what ad should I show to a user? There, my user, I may not see the same user. Again, what are the features here? Typically, I have user level features, I have ad level features, and I have web page level features. I have all the other stuff. Now, all of this may not repeat, like the user may not go to the same web page and I may not have the same ad. So less repetition or very low repetition of XQs. Here, this is useless. Does that make sense? Again, on another example is if a user has not logged in and he just goes to netflix.com, as rightly pointed out by Dhimat in the chat window, I can just say, hey, what are the top videos for this region or for this location? Just store that. Or what are the top tweets for India? Right? You can do that. Okay, cool. Okay, is there any other idea? So Avinash has one suggestion. He says, why can't I use PCA to reduce dimensions? No, PCA does not reduce the dimensionality, keeping the classification task in mind. So always don't forget that. Whenever you think reducing the number of features, don't apply PCA. Here, if you want to reduce the number of features, using L1 regularization is better, because this is done in the context of classification. PCA doesn't care about class labels. It only cares about reducing variance in your data. And I can construct cases where PCA will fail miserably. Anything else? Okay, we got some good ideas, but is there anything else? Is there anything else that you can think of? We are not yet done. Subramaniam has a nice suggestion. Reduce the precision of model parameters. What do you mean? Can you please elaborate? But I like that idea. I was hoping somebody says this. Reduce precision of model parameters. You remember the concept of quantization that we studied in one of the classes? In TensorFlow Lite, there is this concept called as quantization. Right? Where I say, hey, instead of using 32-bit floating point numbers, right? Because multiplying 32-bit floats are hard. Let's convert them into 8-bit integers through some hacks, right? Of course, I can't preserve all the, suppose if my number is 3.26189213, so on and so forth. Maybe I don't require all the decimal places. I just take the first 4 or 5 decimal places. I convert this into integer. Let's assume I use only the first 4 decimal places. Let's write it down. Or the first, let's say first 5 decimal places. Or maybe just the first 2 decimal places. Forget about it. Right? And I want to use maybe 8-bit integers or 16-bit integers. I will only store 326 as my weight. Suppose if this is my weight j, and I'll multiply with this, I know that everything has to be divided by 1000 later. That will be one division because integer multiplication is cheap. Again, very nice. So this solves 2 problems. It makes your systems more memory efficient and speeds up. It speeds up like crazy, right? You can easily get a 5x speed up in this, easily. Sandeep has another very nice, but has everybody understood the concept of quantization? That's a very good idea. Subramaniam, that's a very nice suggestion. Sandeep has another idea. Sandeep's idea is this. Sandeep's idea is, hey, in my input space, can I somehow break, suppose this is my input space, I will break this into regions, right? I'll say, hey, this is my one region. Let me call this R1. Maybe this is another region. Let me, again, based on cosine similarities, right? He says, hey, if a point is here, then I would say that, hey, your YQ hat is 1 or 0. But the problem is this, I want a probability score. Boss, I want a probability score. I don't want a class label. In such a case, this may not work as is. Of course, you can make it work with lots of hacks. But again, finding which region a query point lies in, that itself is another big problem, right? Where you need to use ideas like locality sensitive hashing, which adds up more compute for you, right? Any other ideas, guys? I think we've arrived at a very good set of ideas. Very good set of ideas, actually. One more small hack that we can do. Any other ideas before I tell you one more thing that comes at the top of my mind? Any other suggestions? Okay, so here is another suggestion that you can use in some cases. But we say this idea in interview. Okay, so if you tell me this idea in interview, I'll say, please get me the probability score, right? And how do you determine given an XQ, which region does it fall in? Doesn't that take a lot of computes? Because to compute cosine similarity, you have to still do, suppose if I have some point here as my representative of this region, I have some point here which is representative of this region. My problem is I have to do a dot product with this, I have to do a dot product with this, I have to do a dot product with another region. Isn't that more compute intensive than just doing one dot product, which is W transpose X? Right? So, I mean, just make sure that your compute is not changing. This has to be done during runtime. Sandeep, think about it. I give you a query point. You have to first determine which region does it lie in. To determine which region does it lie in, you have to do a dot product with this sample point, sample point, sample point. You don't know your query point beforehand. Okay, this breakup you can do offline, but you got a new query point. How do you know which region does it lie in? Determining that is more expensive than computing W transpose X plus B. If you have 3 regions, you're doing 3 dot products here instead of 1 dot product in W transpose X plus B. So think of time complexity. Before you say suggestion, think about it carefully. Okay, so one more suggestion is, again, this works only in some cases. If your dimensionality is very large, right? Again, this happens a lot in internet companies. I've worked in these situations. That's why I learned this on the job. If your dimensionality is very large and your XQ could be a sparse vector, right? Because you have some one-hot encoded features. That happens a lot, right? It could be sparse because of one-hot encoding or other ideas. Sometimes features may not exist for every query point. In this case, one hack you can do is, you can create a dictionary. Again, only in this case it makes the most value, right? What happens is, if this is sparse, okay, if I do a simple XQ W transpose XQ plus W0, right? How many multiplications am I doing? I'm doing D multiplications and D plus 1 additions. Think about it, D plus 1 additions, right? If I don't do it, but if I know that its vector is mostly sparse, suppose only 10% of values are always non-zero, then why should I do D multiplications and D plus 1 additions? I can do this. For every feature, so I have feature 1, I have feature 2, so on and so forth, feature D, again this is large, I have the weights, weight 1, weight 2, so on and so forth, weight D. I store this in a dictionary, right? Then what I do is only for non-zero values, right? Only for, so perform W transpose XQ only for non-zero, I mean do this dot product only for non-zero XQJs. Do this multiplication only for that. Then what you end up, if typically your vector has a 10% sparsity, right? You have 0.1 D multiplications and 0.1 D plus 1 additions, right? And this is like almost 10x. So this sort of hack, wherein instead of directly doing dot product, doing the dot product only on non-zero values, because again, it's not that the weights are zero, it's that the input vector is sparse. Does that make sense? Again, here, all these weights may have values. I've already done L1 regularization. I've removed the useless features. These are all useful features. But in my input vector, because of one-hot encoding or other reasons, this vector is sparse. Again, we've seen this in our course, right? When I encode text using TF-IDF or bag of words, it's going to be a very sparse vector. Do you remember this? This is one hack also that you can do in this case, especially when dimensionality is very large and XQ is sparse. Okay, cool. Again, always whenever a question is asked like this, think of all the cases. Right? Think of all the cases and say, hey, in this case, probably I can try this. A lot of times the interviewers also ask you these as follow-up questions, because I used to ask this as a follow-up question. Hey, if my dimensionality is very large, like if my dimensionality is 100,000 and my XQ is sparse vector, what can you do? Right? Based on the size of the query data set, look at the number of resources via multi-threading. Okay. It helps to reduce latency. Subramaniam, I agree with you on that. Yes. Avinash point is sigmoid involves a formula with exponential calculation. Rather than directly applying sigmoid, can we approximate the sigmoid function to reduce compute time? So Avinash, the exponential implementation is fairly efficient in most programming languages. But if you don't put the sigmoid, you don't get the probability value. That's a problem. Right? You can do a hack there. So there is one hack that I've seen people try out there. Okay. So remember, I get my ZQ as W transpose XQ plus W0 or B. Right? I get my ZQ. If I want my probability, if I want my YQ hat, which is a probability, if I want it only for two digits of decimal accuracy, if I only want that, right? If I only want 2 digits of decimal accuracy, I don't want like 10 digits. Then I've seen people do this. They take the ZQ. So this is my whole possible value. My ZQ in my data set can range in anywhere, right? This is my ZQs. They say, hey, if ZQ lies in this region, let's say ZQ lies in the region of 10 to, let's say 11.2. If it lies in this region, then I would pre-compute this. Look at this. I would pre-compute this. Then the sigmoid of ZQ is your YQ hat. Because I only need 2 decimal places. Imagine this is 0.18, right? Then 11.2 to 16.3. I'm just putting some numbers here. Bear with me, right? Here it is 0.19. Because I only need 2 decimal places of accuracy, I can break my whole ZG region. Right? This whole thing I can break it into intervals such that each interval, so let me write the idea here. Each interval corresponds to one probability value. Because if you want only two digits of decimal accuracy, You have only 100 values, 100 probability values. If you have only 100 probability values, I can just create 100 bins, right? I can create 100 bins and I can do a binary search, right? I can do a binary search in this, right? Binary search in 100 bins is very fast, right? So this is a hack that I've seen some people do, but it's a good question. Again, does everybody understand this approach? This is a hack. Avinash, since you asked this question, I was quickly thinking about it. Does this make sense to everyone? I think somebody suggested this. So Subramaniam says, can I use something like alpha tensor for faster matrix multiplication? You can. Theoretically, you can. But alpha tensor itself has its own, like for example, matrix. See, that is best for matrix multiplications. We don't have as many matrix multiplications. We have matrix vector multiplications, which are anyway very efficiently implemented with vectorization in Xeon processors. If you want to matrix multiplications, like in deep learning, then something like that makes sense. Okay, but we have mostly matrix vector type setup. So Sandeep says, can you please summarize all the solutions? Sandeep, that's impossible. The reason is I've gone follow-up questions in some cases, right? So all these are ideas. I'll share all the notes with you, right? So this can work in some cases. Again, it's all about, a lot of times in interview, what happens is, again, my objective here is not to teach. My objective here is take your ideas, ask you follow-up questions, tell you where things fail. Right. I'll share this whole notes with you by the end of the session. Again, I anyway share it with my team. They'll upload this video hopefully by tomorrow and put the notes, right? So it's hard to, because there are multiple threads that we go down. So it's impossible or very hard to summarize this. Not impossible, but hard. So let's go to the next question. Okay, since we have spent good amount of time here. Again, we can spend, like I've been in interviews where I spent a whole 1 hour interview just on this. Right? I go ask variations. Like how do you do it with distributed systems? How do you do it with GPUs? And if somebody says, hey, I've written a lot of GPU code, I ask that. If somebody says, I used PySpark, I used Spark MLA, but I say, how do you do that there? Right? So you can go very deep into this. Okay. Now here is another question for you. Okay. So this is my question too. Think about this. Suppose you are using a MapReduce system. Right? Again, you have your Hadoop as a MapReduce system. You have Spark as your MapReduce system. Okay. Of course, Spark also has in-memory optimizations, etc. Let's assume I have a MapReduce system. Suppose I want you to implement this for me. This is a question. How do you do distributed? Again, I want you to implement from scratch. Distributed hyperparameter tuning. I'll explain the problem. So you have some model. You have a hyperparameter. Let's assume I have a hyperparameter lambda. Okay. Let's assume logistic regression for simplicity. I want to do distributed hyperparameter tuning using a MapReduce system. How will you write? Again, my question to be very specific is, what will your mapper look like? Give me the intuition behind it. What should go into the mapper? What should go into the reducer? Let's keep it simple. Of course, I can go into more complexities. What should be your mapper function? What should be the logic behind your mapper? What should be the logic behind your reducer? Of course, imagine your whole data lies in a distributed data store like HDFS. Right? Your whole data is already distributed across multiple computers. Now the question is, again, let's also make some assumptions here. My data is in my HDFS. Data is not too large. Okay, so let's assume my data is okay. So my let's also write more details. Suppose I'm trying to use it for simple logistic regression, nothing very fancy. Okay, my data is about, let's say, 10 million rows, not too large, but I want to see my data is not large. Okay, my model is also simple. My objective, the core of my question lies in how do you do distributed hyperparameter tuning? Of course, we can make this question very, very complex by picking a complex model. Here I'm using a simpler model, right? I'm also using small data, like medium scale data. It is by no means large data, right? Again, you can use Hadoop Spark as your setup. So I want you to think of what we will write in the mapper, what we will write in the reducer. Again, for those of you, again, this is what happens very often is a lot of questions that we've discussed for data analysts, data scientists also get asked for machine learning engineers. But I wanted to create machine learning specific stuff. Okay, so, some of you probably forgot the concept of MapReduce. So I'll show you one image, which hopefully gives you a summary. Just give me a second. I actually assumed that some of you may forget this. Okay. Again, I'm just, this is a machine learning course. I forgot which university. This is CSC 6250. Sun Lab. Which university is this part of? Let me just check. I've just taken this image and kept it handy. Sun Lab is at, it's a research. Okay, where is this? Okay, I forgot which university this is part of, but that's okay. So if you want, I really like this simple diagram. My bad. Okay, one second. Let me just use it in a new tab. Okay, so this is what happens in your MapReduce, right? Your data is in HDFS. Your data is split into chunks. Each of this split could be stored on different computers. In a mapper, you basically mention what are the keys and values. For this whole data, you have to mention what is the key, what is the value. Right? That's the purpose of mapper. The shuffler, what the shuffler does internally is, again, this shuffler has two subparts, sort and send and merge. So this is happening inbuilt in Spark or Hadoop. Right? What I care about is how do you now split your data into key value pairs. What shuffles does, again, I can also define my shuffle the way I want, but the default shuffle will use. Default shuffle, what it does is, wherever I have given same key value, all of them will come to one box. That's guaranteed, right? So if see, key 1 is there, all key 1s will go to one box. That's guaranteed. And on top of it, I do some function called reduce, and that generates my outputs. Right? So again, shuffle, I'm using the default shuffle. I'm not asking you to change the default shuffle. All right? So basically in Mapper, you have to, for each of your rows of data, you have to say what is the key value, assuming that you have a standard shuffler or a default shuffler, which guarantees that wherever you've given the same key, all of them will go to the same compute node on which a reduce function is executed, and then you get the output. This is the core essence of MapReduce. Of course, if somebody says, hey, I have 5 years experience in MapReduce or Hadoop, I say, hey, let's change the shuffler also. Let's not go into that right now. Is this helpful? This is like a one single image summary of MapReduce. Now think about it. Again, I'm asking a simple question. All you need to know is how does Mapper work? Shuffler anyway is simple. How does reducer work? How does distributed processing happen in a MapReduce? Think about it. So this question is very common for beginner or entry-level folks, where people say, hey, I know MapReduce or I know Spark. If somebody says in their resume, I know Spark, this is like an entry-level question. Okay, so some of you are suggesting some ideas. So let's write down. Okay, so how should my mapper look like? Again, each of this is one row of data, right? So my XIs, right? Again, split 1 will have a bunch of XIs, split 2 will have a bunch of XIs, so on and so forth. So my data is XIs. Of course, XIs and also my YIs, right? XI, YI pairs. So let me write that, sorry. So my each of these data points is XI, YI pairs. So Sandeep says lambda is key and data is point value. Okay, Sandeep, Venkatesh, let me write it. K equals to lambda. Okay, so suppose I have multiple lambdas. Okay, Suppose I have lambda 1, lambda 2, so on and so forth, some lambda k. I want to try all these lambdas. So let me use lambda j to represent this, right? So lambda j I will use to represent this. K is lambda j followed by data point is value. Which data point? Venkatesh, that's unclear for me. Okay. So which data point? So my question here is which data point? Okay, I get your question. I get your point that lambda j can be my key. Okay, but which data point should be my value? Which xi? So you said xi. Which xi? Can you please elaborate on that? Sandeep says break the data into chunks. That's already done by HDFS, na? I don't have to split the data. HDFS has done that for me. Each chunk will have the same key. Why? Why should each chunk have the same key? Why should split 0 have the same key? If they have the same key, split 0 will go to your, again, this reduce happens on some box 1. This happens on box 2. So what? It's not solving my problem. So Sridevi says grid search might work for combinations. So Sridevi, I'm not going to grid search. I'm just giving you a simpler case. I have only one parameter or one hyperparameter. I'm not even going to grid search all the combinations. I just have one hyperparameter. Let's think about it. Jaya says, okay, so this is one option. Okay, second option that someone is suggesting is that my key is chunk index, which is split index. Okay, and my value is hyperparameter lambda j. My v is lambda j. Okay, hyperparameter. My k is chunk index, which means you're saying split number. Why? Why should this work? Can somebody help me? Natarajan says all chunks share all keys. No. So look at this. The way it works is this. Okay, so I think there is some confusion. My data is anyway chunked into, again, this is one chunk, this is second chunk. Let's call it splits because that's the terminology used here, right? Now, each of these chunks, again, this could be stored on box 0. This could be stored on box 1. This could be stored on box 2 and so on and so forth, right? In each of those boxes, there is a mapper that's going to run. Again, sometimes two of these splits could be on the same box. The mapper can only see the data which is there on that chunk, right? So there is no key already in the mapper function. Again, we have to implement the mapper function. In the mapper function, I'll say, read each of the xis and then construct, tell me what key and what value you want to use. All chunks share all keys. I didn't understand your point, Natarajan. But whoever have suggested these ideas, right? Jaya and Venkatesh, is this clear? Where I'm headed? So Jaya, suppose I do this, right? If this is my point, then what happens? Into this box, I will get everything that is there in split 0. Here I get everything that is in split 1. How do I do hyperparameter tuning now? I want to train my model on the whole data. Anurag says key equals to hyperparameter. Actually, I like this thought. This is one way to solve it. Key equals to hyperparameter. Okay. The second thing you're saying is this part was unanswered. Value equals to split index and metric value. Split index, okay. First of all, I don't get split index to start with. But let's assume there is some way for me. Of course, there are some internal functions I can get, okay. So I get split index and what is my value? Split index, comma, metric value. What is my metric value? By doing this, how am I training my model with all, see, what is hyperparameter tuning? Train your model with all hyperparameters and get me the performance value. Okay, so this also I didn't understand how this works. I think many of you may have forgotten how MapReduce works. That's the reason you're feeling this gap. Okay. So Sandeep says, break the data into chunks. It's already broken. To each chunk, give the same lambda. Okay. To all the chunks, give the same lambda. Okay. Each chunk computes and then send to reduce. Reduce computes the average. Write the function, Sandeep. Please write the pseudocode. I didn't understand what you're trying to say. You're on the right track, but you've mixed too many things. Again, if a lot of interviewers say that if it's not clear, please write the map function, write the reduce function, write pseudocode. I don't care about correctness of code. Then send lambda 2. Again, Sandeep, if you're doing iterative, right? I think you're coming to some iterative algorithm. The problem in iteration is, if I'm running map and reduce iteratively, what's the point of doing distribution? I might as well run this on a single box with 10 million points. I can do this in a single box. So Venkatesh, for each chunk, we can assign each of my data to any of the keys. Okay. Venkatesh, you're thinking right. Your initial thought was very nice. You're thinking on the right direction. Can you tell me the exact pseudocode? Write the pseudocode. Okay. Good. Okay, so this was not clear. Again, please elaborate if in case I didn't get what you're saying. So Avinash wrote it very simply. My key is lambdas, lambda j's. My values are each xi comma yi pair. All. So my code now will look like this. My code will simply say, because this on split 0, the code will run on one compute node. On split 1, it can run on another compute node. My logic is simple. Okay, read each line, my mapper. Right, my mapper code. Okay, let me write this. Okay, so let me write the logic itself so that it's easy. Okay, I'll write the pseudocode. Right, my mapper, what it does is read each line. Read each line of data. Whatever data, whichever split I get, read everything. Then output, what do you want to output? Okay, so then write a for loop, right? For each lambda j, because you know that lambdas you want to try in a specific range, right? So you might be trying from a range of 1 to 1000 values in intervals of 10, 1, 10, 20, so on and so forth, right? For each of this, you simply say, read each line. Okay, so let me put it in a, okay, so let me write it more properly. My mapper code will simply say, for each line, for each xi comma yi pair. This is one line of input that I'm reading, right? In my whole matrix. For each lambda j, simply output key equals to lambda j, value equals to xi yi. This runs in each mapper. So what happens now is, by the time I come to reduce, okay, because I have only 10 million points, my data size is 10 million points. All right. So by the time I come to the reduce stage, what happens now? This is where things get very interesting. All my points, my whole data set comes to each reduce. 10 million is not large. And I get one lambda j. Now in the reduce part, what I'll do is this. This is my input to my reduce. My code in reduce is build the model. Using the whole data set D, right, and lambda j. Get the performance metric, right? Get the performance metric on your both train validation. Again, some of this will be train, some of this will be validation. That's okay. Then output that, write it to disk. Just write it to disk. Does that matter? Does this look good now? This is what my reduce code is. So what is effectively happening is, because I have only 10 million data points and 10 million data points can be trained on one node, effectively using MapReduce, what I'm doing essentially is, All this data I'm sending to each of my boxes. The same thing happens in this box also. Each of these boxes I'm sending whole data. On each box, here I will try lambda 1, here I will try lambda 2, so on and so forth. So I'm doing the distribution primarily for training K models parallelly. Does this make sense? Again, this is one way of solving it. I'm not saying this is the only way. This works this is the simplest possible solution. Because our data is small, our model is small. Okay, let me see your thought process. So Avinash says, okay, each map box will read all data points. No. This map box, so this is, let's say, mapper 0. This box, let's assume, is only reading split 0, and let's assume it's reading split 3. That's okay. In split 0, let me call this as D0 and D3, right, which are two parts of my data set. So for D0 and D3, whatever lines it has read, it is giving output for all lambda j, right? So it is guaranteed D0 with, let's say, lambda 1 will go to this box. Does that make sense, Avinash? Again, some of you who may have forgotten how MapReduce works, please check out our course videos which we've done through live sessions where we explain how does mapper and reducer work internally. Okay. Again, if you say I know Spark or I know Hadoop or I know MapReduce, this is probably one of the easiest questions you can expect for entry-level machine learning engineers at product-based companies. I can make this problem extremely complex by asking you things like, okay, my data set is very large. How do you now do MapReduce? First question. My model is very complex. How do you do this? For that, you have to understand how MLlib works internally. Actually, this is how, there is this library called MLlib, right, in Spark. Right? This is how MLlib internally within Spark does distributed hyperparameter tuning for simple models if the data can fit in a single box. So Sandeep says, why can't we distribute compute of each W transpose X dimension wise? Okay, by doing that, what do you get? You're not doing hyperparameter tuning there. So Sandeep, if your point is, again, how do I get my W? I don't know W at the time of training. I have not trained any model initially. I don't have a W. If I just take some random W, this makes no sense. Here, I'm building my model here, where I'm discovering my W in this setup. Right? If you say, hey, I'll send some of this to one box, others to other boxes, and I'll build models there, you're building models only in a subset of data. Ideally, when I do hyperparameter tuning, I should build it on the whole data. Again, don't think from an iterative mindset. Typically, we are used in machine learning to think from a gradient descent or a stochastic gradient descent perspective, where we think of everything as iterative. Doing iterative MapReduce is very expensive. Sandeep, please write your pseudocode. Tell me how you do it. Then you will understand. That's why I wrote the pseudocode here. Just write the steps. Okay, Venkatesh has a point. Can't we assign each data from each chunk to any of the keys? Okay. Maybe, okay, from some uniform distribution. So you're generating your keys uniformly. Okay. Right. Each chunk to any of the keys. Okay, randomly you're doing it. Maybe the sample for each hyperparameter is sufficient enough to compare. No, that's not necessary, right? So Venkatesh, what you're suggesting now is you're saying, hey, I will not build the model on the whole 10 million data points. I will only build it on a subset of it. And I will only do hyperparameter tuning by looking only at a subset of data points. If I have to do that, I'll do it on my laptop now. Why do all the distributed computing for it? Right? I want to use all of my data to start with. It could so happen that I have 1,000 features. But I don't want to throw away my data. or I have 10,000 features. I don't want to throw away my data. See, if your solution is that I will train my hyperparameters on this, then I don't require MapReduce. On each split, on each mapper itself, I'll train a model. I'll try all the lambdas, and I can have a pure mapper only code, trivially parallelizable. What's the point of writing MapReduce code for that? But the more fundamental gap in that solution is, hey, why are you doing hyperparameter tuning only on a subset of data? I would ideally want to do it on the whole data. Does that make sense, Venkatesh? Okay, I hope this gives you a sense of where we are going. Sandeep, again, I did not understand your solution, so please write that short pseudocode so that I can understand what you're saying. Dhimat says, can we take transpose of some features and send a subset of them like random forest? Dhimat, you can do that. See, I mean, I would suggest, okay, so there is a very nice research paper that I would recommend you to read, or read the source code itself. It's a very old paper that I remember. Let me see if this code is, this is the official documentation. Because I've been using Spark for a very, very long time. I read some of the original research papers and code snippets. This is from 2016. Let me just open this up quickly. One second. No, this paper doesn't have it. This is just a summary of things. One second. Just a second. There is this old research paper that I remember. Or else probably it's just better to read the source code. Okay, so let's do. So Dhimat, what you said actually is done by Spark, because if I have to pick only a random subset of features and send them to different boxes, and on each box, imagine there is a decision tree being built. That's exactly how Spark builds random forests internally. So it does that already, by the way. Logistic regression. So these are all the models that you have, basic models. Now there is also a data frame based thing, pipeline prediction. The data frame based thing is more recent. See, there is decision tree classification. There is GB. There is random forest classifier here. I remember reading this. Okay, this is the Wikipedia page. I'm sorry. This is just the code. This is not the internals of how it works. Again, the best place sometimes to read how distributed systems work is just go, okay, let's just do this. Actually, unfortunately, some of the code is written in Scala. Okay, so this is, one second. This is the original source code, Spark ML classification. So this is the Scala code. My bad, sorry, just give me a second. So the way Spark works is, Spark's core code is written in a functional programming language called Scala, which runs on a Java virtual machine, and PySpark is a Python interface to that. So this is the original implementation, Spark MLlib. This is Scala code for random forest. Again, even if you don't know what Scala does, you can see it and get a sense of what's happening. So this is about some 500-600 lines of code. You can read it and see exactly how that works. Okay. In case you're interested. Again, even if you don't know Scala, that's okay. You'll get a sense of what's happening. So let me quickly share this link in case you're interested to read. Okay, cool. So that's one aspect of it. Hey, I also wanted to suggest something for all of you. There is this very nice, because students have asked me this in the past. Okay, cool. So this is one resource that I would request everyone to go through. This is a very nice course at Stanford. This course is taught by Chip Huyen, who is a co-founder of a ML Ops company. Very interesting company, and she has taught this course in the past. I don't know if she's still teaching this course. I'm not sure, but it's a very nice course with lot of very good lecture notes, lecture slides, etc. Right. So for those of you who have, let's say, 5+ years of work experience as software developers, who want to go through little more internals of machine learning system design, this will be very, very helpful to share that resource with you. This is probably the best, if I recall correctly, at least when I last checked, maybe 6-7 months back, this was the only machine learning system design course that is offered anywhere in the world, to the best of my knowledge. At any of the, again, of course, at Stanford, you can expect very high quality. The good thing is this is designed by people who are in the industry, not just in academia. So people who are building MLOps systems, they are the best people to teach you this. Right? So it's a very nice course. So I had one question. Again, I'll show you I'll not tell you what the solution is. But here is one other type of question. Just in the interest of time, I wanted to cover a few more things. One other type of question which is very interesting is, how do you build a model monitoring system? Again, this is for people with little more experience. Right? Imagine if you're a software developer with 5+ years experience. Suppose I want to build a system which monitors if my models are going good. How would you design such a system? Right? So that's a question. Now you should think of how to answer that question. So to answer that question, again, I'm just giving you a bunch of questions and pointers on how to think. Okay. So for that, there is this very nice lecture note, which I would recommend. It's just a Google, it's a very nice Google, it's basically a very detailed Google document where it says how to monitor all the cases that you will encounter, all the stuff that you'll go get into, monitoring of data, monitoring of models, that whole problems that you'll encounter in the real world. Again, I would recommend you read this. There are lots of nuts and bolts in this. This is about how to design a system. First, think of where all will ML systems fail in production, right? Of course, it could be data distributions that could change. What types of data distributions occur and what sort of methods I can use to detect. Then you can monitor ML metrics, right? You can monitor the features, you can monitor the distributions of predictions, raw, non-featureized inputs, right? And how you can build a dashboard or alerts based on that. So this is very good. Again, this is a detailed read. This is less of a deep technical stuff, more of making you think of all the things that can go wrong and how to design a system like that. Okay. So for those of, how many of you have 5+ years of industry experience in this as software developers in this crowd, or people who have designed software or built software? Okay, I wanted to put one question. So this is a type of question that you can expect at top product based companies, because you're not being considered for an entry level machine learning engineer. You're typically considered for ML engineer 2 or ML engineer 3. So please follow this. This is a terrific resource that I loved reading the last time I read. Okay, so this can help you become very good at system design on how to think of all the pieces. Again, in system design, the most important thing is list down all the things that can break down. For each of them, build subsystems. Right? That's what is expected of a senior person. Okay, so one more question that I had. Again, this question I want to ask as a question, but I realized that this is too broad, given that there may be very few people with a lot of experience. Okay, so another question that I have, this is an entry level question again, right? Can you please write a library for me? Create a library that I want to use across my company, right? Wherein I just give one feature. Okay, what should it do? What should this library do? Given n observations, I don't care what you do. You tell me, given n observations, you please write a library. Again, I've seen this question being asked in a 1-hour interview also, or something like this. Similar questions where you're asked to write code along with you. Okay, this is like an interview where you work with the interviewer and write code. Given n observations, write a library to suggest the best probability distribution that fits this n observations. The best probability distribution and the parameters of the distribution, right? You should also return the parameters of the distribution that fit the n observations. How will you design such a system, or how will you write? Again, this is, I've seen variations of this question, sometime being 1 hour or even 1.5 hours. It's like a full-fledged 60 to 90-minute coding, live coding type of interview. I see a lot of startups do this, but of course, even large product-based companies sometimes do that. Right? You say, please open your Google Colab, please share your screen. Let's implement a library. Let's implement the classes, whatever you want to implement, wherein I'll give my input will be, you can even just implement a simple function. That's okay for me. Okay. I'll give you n observations as your input. Please tell me the probability distribution and parameters that fit the n observations. Is the question clear? This is like a live coding thing. Is the question clear to you? Again, if you can suggest me your thoughts on how you do it. Folks, is the question clear to everyone? Can you just confirm that? Because I'm not hearing any feedback from you. Question is clear. Okay. I was just checking if I have a technical glitch. Okay. Please suggest your thoughts. Okay. Good. How do we solve this? Okay, Sandeep says this won't be done brute force, like compare it with known distributions. Can we build a function like QQ plot inside our function? Okay, but how do you do that, Natarajan? So, you know a bunch of techniques, right? To compare some data to some distributions, you can use QQ plot. But again, you have to compare it with probably multiple distributions, multiple classes of distributions. Sandeep, what you said is right. We may not want to do brute force, but okay, even brute force chalega. What other techniques do I have? So Avinash, you have a question about two parameters. Okay, this is the previous question. Okay. If there are two parameters, number of reduced boxes will become m cross n, m comma n. So Avinash, okay, just hang on to that question. As soon as we finish this, I will answer that question so that we are not going back and forth. Just hang on. I'll ask you to post your questions. I think there was one more person who had a question that I said we will do at the end. Okay, so I'll just hang on to that question. I get your question, but I don't want to detract from this question, but I'll do that at the end. KS test is another idea from Sandeep. Okay, good. Again, here it's also about how do you break a problem into sub-problems. Can we start by scaling all the parameters? What do you mean by scaling the parameters, Dhimat? That I didn't understand. I just have n observations. I want to find the probability distribution and the distributions parameters. Jyoti has a good point, which is, okay, so Natarajan says compare with all distributions. Let's get a list of all distributions, do KS test, wherever the p-value is comfortable, right? We'll just say, hey, this probably is it, okay? First, scale the features. Why should I scale the features? Not necessary. Why should I always normalize or standardize my data? Why should I normalize my data? Who said my data is numeric? I never said. I never said my data is numeric. So first thing, whenever somebody says, let's find probability distribution, first, if else condition, is it discrete or continuous? First thing. Right? First, like you should first break it down. This problem is less about, of course, there is some aspect of knowing about what test to use. It's also your problem solving skills, right? First, see whether it's discrete or continuous. Within discrete, you can make a list of distributions that you want. Maybe distribution 1, distribution 2, distribution 3 that you want to try, right? Within continuous, maybe again you have distribution 10, distribution 11, all these distributions that you want to try. Is there any other breaking down that I can do? Sandeep says we randomly split in multiple chunks. Oh, you're trying to parallelize. Okay, so what if your n is small? N is, let's say, 100. I never said n is large. So, of course, if n is large, I can do some parallelization. But I never said n is large. So Kapil says writing formulae to compare distributions. Which formulae, and by using formulae, how do you compute? Is everybody clear? Has everybody gotten this concept that first we should check if my data is discrete or continuous? That I can easily check, right? I can easily check if my data, if my observations, if my random variable x for which this thing is there, is it discrete or continuous? That I can do it, right? Then I should only focus on discrete distributions and continuous distributions. Subramaniam says, can I use kernel density estimation to do what? If you're doing kernel density estimation, you can get your CDF and PDF. You can get your PDF, or you can get not even a PDF. You can actually get a smooth histogram, to be more precise. You get a smooth histogram, right? Because to get exact, to get PDF, by getting smooth histogram, how do I know what distribution belongs to what? So everybody got. Is there any other? Okay, so let's say of course there are more complex things. If I know that something is continuous, I can break something into exponential class of distributions and non-exponential class of distributions. Again, there are some specialized tests for it. Okay, so exponential class of distributions will contain things like Gaussian, Expo, all of those, right? There are also long-tail distributions like normal, Pareto, etc. There are tests to say what is a class of distribution. But let's assume we don't know that. At least the simplest solution I would expect is, okay, first step, determine whether it's discrete or continuous. List down everything that I can get from SciPy. Just go to SciPy's documentation. If I were writing this myself, just go to SciPy's documentation, get all of them, right? Then, so this is the second step, get all the distributions. Third step, for each distribution, compute the parameters of the distribution. For each distribution, right, for each di, or let me call it dj, for each dj distribution, compute parameters. Because without computing parameters, how will you do KS test? Right? Your parameters could be some theta. These parameters change from distribution to distribution. Right? Fourth step, do something like K. Of course, KS is not the best test, but that's okay. KS test between my n observations versus my distribution j with theta as my parameter, right? And fifth step, right? Fifth step is whichever has the best p-value, whichever gets the best p-value, output that distribution. Simple. Sandeep, that's okay. Don't worry. Is this clear? Again, this is a very simple task. Again, of course, if somebody comes from statistics background, all right, I would expect, or math background, I would expect them to break this further and say, hey, continuous distributions, I can break them into multiple classes of continuous distributions, like long tail distributions, right? Like Gaussian-like distributions or symmetric distributions, right? You can break it down, right? Symmetric, right-tailed, long-tailed. There'll also be these distributions, right? This is right-skewed, left-skewed distributions. Within this, there will be some more subsections, and I can find out if my data is symmetric, left-skewed, right-skewed, and then within right-skewed there will be some distributions. I can do all those optimizations. That is second level of optimizations, right? So further optimizations are possible here. Further optimizations are possible based on the classes of distributions. Sandeep says, plot the model. I think you mean, okay, build a computer vision model to compare. Interesting. Okay, Sandeep, that's an interesting thought. Okay. So what Sandeep is saying, this is nice. This is slightly out of the box. Sandeep is saying, plot the PDF, right? Build a computer vision model which says, hey, if this is the PDF, what all distributions could it be? And then only check that. That's a neat idea. I've not thought about it. Okay, but sounds like a plausible thing. Slightly overkill for this, but plausible. Can we use Chebyshev's inequality to get percentage of points within a range and compare it? So, by the way, Avinash, Chebyshev's inequality or Markov inequality works for all distributions. Remember, what does Chebyshev's inequality say? Let's go to Wikipedia quickly. Right, Chebyshev inequality works for all distributions. It's got nothing to do with Chebyshev. It's a distribution. Okay. It has got nothing to do with distributions. I think its only condition is that k has to be non-zero. So look at this. So for any distribution, if x is a integratable random variable, which means it's continuous random variable, with mu, which is finite, and non-zero variance. As long as mu is finite and it's as long as you have finite non-zero mean, as long as you have a mean and a finite non-zero variance, as long as you have this, for any real number k, this inequality holds. It just got nothing to do with distribution. The only requirement from the distribution is that the variance is non-zero and finite. That's it. That's the only expectation. And of course, k should be greater than 0. No other expectation. It's distribution agnostic. That's right. Okay, so I hope this gives you a sense of how to think of some of these problems. Again, I've tried to collate mostly problems from pure implementation perspective. But for a machine learning engineer, expect yourself to write a good amount of code in your interview loops, because that's expected out of you, number one. Number two, expect questions that you get for data analysts and data scientists also. Okay, so that's one. Second thing is, again, a couple of you had some questions which I said I'll discuss at the end. I think there was one person at the beginning. Let me just recall that person. Saujanya, can you please post your question here, Saujanya? That's one. I think Avinash had one suggestion here about whether it was Avinash or someone else. Sorry, Avinash had one question. Saujanya, when you post your question, let me just quickly answer Avinash's question. So Avinash's question here is, imagine if I have two hyperparameters. Right? I have two hyperparameters, let's say lambda 1 and lambda 2. Let me not call lambda 1, lambda 2. Suppose I have, let's say hyperparameter 1 and hyperparameter 2. And if there are m values of this and n values of this. So does it mean that I'm going to get m cross n data sets? Which means, do I need m cross n boxes? Because you said, hey, reduce goes these m cross, say, for example, there is one value, right? So for example, HP1 is 10, HP2 is 12. So for this combination of 10, 12, right, I'll get all my data set in one box and I'm going to train my model. So to answer that question, what happens is, again, look at how MapReduce works. As long same key, all entries, right, with same key are guaranteed to go to, to go to same reducer. Are guaranteed to go to same reducer. That is guaranteed. Right? So your whole data set with hyperparameter 1 value this, hyperparameter 2 value this. Then my key becomes hyperparameter 1 comma hyperparameter 2, the tuple. Right? So this becomes my key. So this is guaranteed to go to this box. But at the same time in MapReduce, that's why I said please go back and read that. This is very important. It could so happen that 10, 12 data goes here to this box. So let me explain that. It is guaranteed that all the data points, all the entries with 10, 12 surely will go here. But it could so happen 10, 32 also goes here. So then what do? On this data, you first build your model, get your performance values. On this data, again, it will be in sorted order. Okay, it will be in sorted order such that all data point with 10, 12 first appear, then all data points with 10, 32 appear next. Right? So you build your model 1 with 10, 12 as your hyperparameters and do this. Then you build your model 2 with 10, 32 and get your performance metrics. Does that make sense? Who asked this question? Avinash. So anyway, Saujanya, okay, I would like to send my query. Okay, Saujanya, let me do one thing. Have you sent a mail to our team already? If you have sent a mail, I'll get the contents of the mail from there. Just message there that please share it with Verma. Okay, and I'll respond to that. Don't worry about it. Cool. Okay, Avinash, you got it right. So cool. Again, Saujanya, if you have not sent your email, please send it in the content. Say I spoke with Verma in the live session. Please share it with him, and I will go so that my team will explicitly send it to me. I will answer it. Okay, folks, so these were some of the questions that I had, but I would strongly recommend, again, I'll share all of these notes with you. The most important thing here is for those of you with a few years of experience, I would suggest you to read this. I've read this, I've read the first version of this ML Systems Design course. It was very eye-opening because even though I worked in the industry, my knowledge is limited to some subsections of the industry, right? I've not worked in every possible machine learning scenario. So this was a good eye-opener for me to learn new things. Okay, so Natarajan says, why we should know the parameters of the distribution before KS test? Don't it work without finding distribution parameters? Natarajan, it can't, right? See, at the end of the day, your KS distribution, you have observed data, you have empirical data. Your KS distribution, or sorry, not KS distribution, your KS test. Well, how does your KS test work here? Your KS test basically says, hey, suppose this is my random variable x. It says, hey, this is the observed CDF from the observed data. And then it will say, hey, this is the expected CDF. Sorry. Anyway, everything has to, okay. Then it says, this is the expected CDF. How do you get the expected CDF? You have to know what is the distribution and you have to know the parameters of the distribution. Without that, you can't plot it. Then it says, hey, what is the maximum or the supremum of the gap between them? The more the gap, again, this is your CDF. Do you remember this? Natarajan, just check how CDF works. If I don't know the parameters, if I just know that it is Gaussian, right? If I just know that it's Gaussian, I don't know the parameters. How can I even draw expected CDF? Okay, so I hope that clarifies it for you. Okay, I can't even draw my expected CDF. Okay. Okay, Avinash question here is, I have one question. I have one query for NLP with attention for, okay, my inference is coming same output for every input. Okay. I have one query for NLP. What is SCS2? Avinash, what does SCS2 mean? Sandeep, I'll share one question and I'll share resources for you to read up more. But self-case, okay, you meant self-case study. So I have one question for NLP with attention. I'm getting the same output for any input. Okay, do one thing. Here is my first suggestion. Look at the probability distribution. I think you're trying to generate characters or sequence of characters, right? Probably you're getting the same output every time because the distribution. See, at the end of the day, how does all these character generation systems work? It looks at the distribution of across all the characters. If I have 26 characters, it says what should be the distribution. It is possible that you're going only one value, and that could happen because your model has not trained. So whenever you get these like crazy outputs, right, do one hack. First, overfit your model. Take a small data, overfit your model. See if your model is able to overfit to the data. Then you know that yes, the model is training in the first place, right? Then you go and look at the distributions of gradients, of weights, when the model is training. In your case, I think there is some bug somewhere where your model is either not training or it is trained on incorrect data. That's my strongest gut feel. Probably when you're training the model, probably for each input you gave the same output. Some hack would have happened there. Again, get help from whoever is the mentor that's helping you. But if you have to make a rough guesstimate, these are the quick experiments that I would do to figure out what's happening. So Avinash, in my first epoch, my validation loss is dropping heavily as compared to train loss. Your validation loss is dropping. Okay, do one thing. Split your train and resplit your train and test, or train and validation. Okay, don't just keep one split. Jumble up everything, use a different random seed and split it again. See if there could, I mean, sometimes this happens. If your data set is small, craziness of the data set seeps into the data. So just change the random state, resplit the data into train and validation, or use k-fold cross validation so that some of these headaches won't happen. Now, somebody saying, can you discuss about one question? So I made a note on one interesting question, which is design a feature store. Again, I discussed about this in the course videos, right? So the question here is design a feature store. It's a very good design question. Again, a lot of companies have designed feature stores. Now, again, I think there's also a course video. I think there is also a YouTube video that I made. YouTube applied AI feature store. Yeah, I remember doing this. Yeah. So this is the video. In case it's there both in the course and here. So please check this. So here I explain what is feature store and how it works. Now the next question for you is design a feature store. Again, it's not rocket science. It's all about using dictionaries properly, using HDFS properly, right? Or whatever distributed data store, or using databases carefully, right? So this is a very common problem that I see, especially for people with few years of experience in the industry, because feature stores have become like de facto standard. Now my question is not what is feature store. That's not my question. My question is, if you have to design a feature store from scratch, how would you build it? Right? So think about that. LSH with dictionary. No, that won't work. No, feature store's objective, by the way, Sandeep, feature store's objective, just to be clear, is not to find nearest neighbors fast. That's not its objective. That's why I said, I remember that many of you may have forgotten this. So check out that video that I've posted, where we explain what is the purpose of feature store. And actually there is a very nice feature store that I have seen from Databricks. Yeah, so Databricks is the company, so Spark is the open source library. Databricks is the company that provides Spark as a service. Right? So again, you can read up about it even on AWS, AWS feature store. Yeah, SageMaker has a feature store. Right, so you can also read up about it. Again, it talks about what feature store does, what are the features. Again, the best place to read about how to design something is to read from people who have been there, built it. Right? I learned a lot from AWS SageMaker on how to do ML ops, ML system design. Like AWS blog is my favorite place to learn high-level system design. Right? Can we share some of the website you used to read about AML startup company and products? Natarajan, AI ML startups. I can't think of anything at the top of my mind. I actually follow a bunch of people on Twitter, and if there is something that looks good there, I just follow. Another place is one second, just a second. There is your Neptune is a good place to also see. Angel List is probably my best source. I was looking for Angel List. Okay. So Angel List, where is my Angel List? One second, angel.co. So Angel List is this very nice website, which is basically like a good place for people to find jobs at startups or to find startups themselves. But of course, this is by no means exhaustive in any way. Like you can say startups hiring in India, all of that stuff. Again, they've become more of hiring platform now. But earlier it was much more interesting. Having said that, as far as I discover interesting startups, I mostly discover from people talking about these startups, doing some really good stuff on Twitter. I mostly use Twitter to learn machine learning. Okay, cool. Sandeep's question is, it's pre-computed feature, then we can be used across different teams. Sandeep, yes. So feature store is all teams put it somewhere, right? Features at various levels of granularity, at user level, product level, whatever granularity. And you have a registry to maintain it. There I don't require LSH, it's just a lookup. I just need to store data in key value stores with low latency, but I also need the data in distributed systems so that I can train models easily. So your feature store is both used at training time and at runtime. And the requirements at train time and runtime are slightly different. So you might have to design your feature store to cater to training needs as well as evaluation needs. So Subramaniam says, will the course content for applied AI remain the same? No, it's going to remain more or less the same. Like even this will get added into the course content. It's not going to change. Okay, sounds good, folks. With that, we'll wrap up today's session. I hope this gave you a sense of what you can expect across a wide spectrum of companies. I'll give you one suggestion. At any point, if you want to practice programming for machine learning engineering roles at good companies, if you want to practice coding, pick any library of your choice. Pandas, NumPy, SciPy, scikit-learn, TensorFlow, MLlib in Spark. Pick any library. Pick any of your favorite machine learning techniques or data analysis techniques or data pre-processing techniques. Implement that from scratch. That's the best way to practice coding for machine learning engineering roles. That's one. If you want to think more about the system design aspects of it, the best place is go to some of the largest cloud-based providers and fast-growing startups like AWS, GCP, Databricks, right? And read, for example, for Amazon SageMaker, they have a very nice blog and they have very nice technical documentation of how things work. Go to the blogs of some of these largest companies and see how they're using it so that you understand the system design aspects of it, especially if you're somebody with at least 5 years of software engineering experience who want to become a machine learning engineer. Those are the two key takeaways with which I want to leave you today. Okay, sounds good, folks. With that, we'll wrap up today's session. See you in the future weeks. Again, anything that I probably missed in this session, please reach out to my team via email. If a question is relevant to me, they'll surely forward it to me and I'll get back to you as soon as possible. Thank you. Have a good night. Bye-bye. Thank you for taking the time on a Sunday. Bye, folks.